Factor affecting SN2 reactions. Number one, substrate structure. This is new alkyl halide, tertiary alkyl halide, secondary and primary and methyl. This primary alkyl halide is the best substrate for SN2 reaction because in this substrate the attack of nucleophile facing no steric hindrance. But in case of this one, the attack of nucleophile from backside facing more resistance due to steric hindrance. So this is the best substrate, and this is the worst substrate. This is very simple. Next factor is effect of nucleophile. First one, keep in mind, a strong nucleophile means which can react with substrate fast, and weak nucleophile mean which can react with substrate slow. The same nucleophile sometime may be acting as fast nucleophile, and sometimes that nucleophile will be slow nucleophile depend upon reaction condition, solvent, temperature, etc. For example, this is methoxide reacting rapidly, so this is strong nucleophile. This is alcohol reacting slowly, this is weak nucleophile. Remember, nucleophile are nothing than Lewis base. All nucleophiles, they are Lewis base. The following points should be kept in mind about the nucleophilicity of nucleophile, strong or weak. Number one, negatively charged nucleophiles are stronger than neutral form of the same molecule. For example, this is alkoxide and this is alcohol. This one is stronger nucleophile, this one is weaker nucleophile because this is charged, unstable, highly reactive. There is no charge, neutral with low energy and less reactive. So in this case reaction is slow. In this case reaction is fast. Although both are nucleophiles, so if there is charge, the charged nucleophile is highly reactive, good nucleophile. If there is neutral, this is not good nucleophile and it is less reactive. Same as hydroxy and water. Now our second point, in a group of nucleophiles in which the nucleophilic atom is same, nucleophilicity is directly proportional to basicity. For example, alkoxide, hydroxyl, this one. In this group of nucleophiles, the nucleophilic atom is same, oxygen, 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 oxygen. So in such group of nucleophile in which the nucleophilic atom is same, increasing the basicity, increasing will be the nucleophilicity, but don't correlate nucleophilicity with basicity anywhere. There is no general rules about the nucleophilicity and basicity. In this series, the order of basicity is increasing. This is the best base, this is the weakest base, this is the strongest base, and this is the weak base. This is the strong nucleophile, this is the weak nucleophile, and they are intermediate. Number third, if the solvent is protic. What is protic solvent? Solvent in which hydrogen is directly attached to the strong electronegative atom, for example in water. So if the solvent is protic, for example water, then going in the family of atom, then going down in periodic table, atomic size will increase and nucleophilicity will also increase. Nucleophilicity will increase, not decrease, but with condition if the solvent is protic. For example, this is fluorine, chlorine, bromine, iodine. Now going down, atomic number increase, atomic size increase, nucleophilicity will increase if the solvent is protic. Why? Let's suppose this is fluorine. in case of fluorine, if we use this protect solvent water, the water will solvate due to hydrogen. The water will solvate this fluorine. Once the fluorine is solvated by the solvent, the fluorine is not available in much concentration to react with the substrate. So the reaction will slow and product will be minimum. This fluorine is solvated by this solvent, and so much solvated because this is more electronegative and more electron, and the size is very small. When the size is small, the electron are mostly localized because these outermost electron, just like negative charge, is under the strict control of nucleus, and they are mostly localized. So the solvent is will try to solvate more this small size. So in this case, this fluorine is not good nucleophile because reaction is slow. Now going down in group, in last there is iodine. In case of iodine, the protect solvent will not solvate this bigger size because these outermost electrons, they are not localized. So the solvation will be slow. When the solvation is not so much, just like this fluorine, so it means that this iodine is much available for the reaction with substrate, and the rate of reaction will fast. So in this case, iodine is good nucleophile. So this is good nucleophile, this is bad nucleophile if the solvent is protic. Now if the solvent is aprotic, in which hydrogen is not connected directly with the electronegative atom, for example, dimethyl acetamide, dimethyl sulfoxide, they are aprotic solvent. Now in this, if the solvent is aprotic, then going down, the nucleophilicity will decrease. The nucleophilicity will decrease. Let's this is fluorine. This is fluorine substrate. Fluorine is not well solvated because the hydrogen of solvent is not directly connected to the electronegative atom. So there is no solvation, and these outermost electrons are localized. They can easily react with substrate and reaction fast. This is good. This one is a good nucleophile. This is bad nucleophile. But this was the bad nucleophile. If the solvent is protic, if the solvent is aprotic, this is best nucleophile. If the solvent is protic, this is bad. In case of iodine, if the solvent is aprotic, there is no solvation, and there is no solvation, electrons are not localized. So when these electrons are not localized and not under the strict control of this nucleus, so they will react slow with the substrate, and reaction will be slow. So this is not bad nucleophile, but this is a weak nucleophile. So that's why going down in the nucleophile, इस case में this is best nucleophile and this is a weakest nucleophile. Nucleophilicity will decrease, and here nucleophilicity will increase. Thank you.